So what we have here is the 2000 and what was it, 80? Yeah, this is the 2010 question 3B on projectiles. Okay, so it's thrown up an inclined plane. So what we'll do is we'll just get our inclined plane going on here. Actually, I'll draw my own one. I like it going this way. So here we go. Here's our inclined plane. Now, what we're going to do next is we'll just draw our generic, it goes up, it goes down, and it hits somewhere up here. Makes the angle, line of projection makes angle 30 degrees with the inclined plane, and the plane is inclined at angle theta to the horizontal. So, theta here, and a 30 stacked on top of that. Everybody alright with that? Okay, first thing we're going to do is we're going to start off with a velocity triangle. What the velocity triangle does is we have to resolve it into components phi x, phi y, sx, sy. Now, oddly enough here, guys, on projectiles, our x-axis refers to this direction here, and our y-axis refers to this direction here. So it's not x and y as you formerly remember it, okay? So what we're going to have to do is, first of all, we're going to resolve the 30-degree angle. It's going up at 80, but I need to resolve it parallel and perpendicular to the plane. So it's going to be 80, that's going to be 80 cos 30, and that's going to be 80 sin 30. And both of them, can somebody tell me what 80 cos 30 and 80 sin 30 is? 80 sin 30, anybody? I think 80 sin 30 is 40, and I'm pretty sure the other one is 40 root 3. Will somebody just check that up for me? 80 cos 30 and 80 sin 30 when you have a chance. Okay. Going to do next is resolve gravity. Gravity can be resolved using a gravity triangle. Go straight down, and then we make a triangle like this. This here, if you complete it all the way down, that's 90 degrees. That makes that 90 minus theta, which in turn makes that there theta. Is that alright? That makes this g cos theta on the way down, and then the way back into the plane, it's going to be that's a g, by the way. It's going to be g sin theta. Everybody cool with that? Is everybody cool with 40 root 3 and 40? Okay, you've checked it? 80 cos 30, anybody? And then 80 sin 30. Now, we're good? Okay. Eventually, we're good. Now, what happens next is this, guys. We're going to get phi x and phi y. Phi x is based off phi equals u plus at. S equals ut plus a half at squared is what where s, x, and sy come from. Okay. Just going to reread the question one more time. What exactly are we looking for? Particle strikes the plane at an angle. We're doing a landing angle here, are we? Landing angle. Sorry? Yeah, I'll do that now. So guys, what we're going to be doing is a landing angle. We'll call the landing angle alpha, if you don't mind. So, tan alpha equals 2 over root 3. Now remember, when you're landing, you have two components to your landing. You have a you're landing at a diagonal right down. Does everybody agree that you're going diagonal right down at the end? Okay, so what you're doing is you're going diagonal right down, but when you compare it to the slope, what you have here is you have a phi x component and a phi y component. Can anybody tell me, will phi x be positive or negative? Phi y? Phi y is guaranteed to be negative, isn't it? And this angle alpha, it's an acute angle, isn't it? What happens if you tan inverse? What happens if you have a tan of an angle, but you have minus 5 and 4? When you tan inverse minus 5 over 4, will you get an acute angle? Where tan is negative, guys, ASTC? If tan is negative, you're not getting an acute angle. That means that we got it, when we're talking about our landing angle, the preset formula is that tan alpha is minus phi y over phi x. The adjustment of the negative phi y value means that you'll now get an acute value, because minus phi y over phi x is guaranteed to be positive. Therefore, its inverse is guaranteed to give you a acute angle. Everybody cool with that? Hope so. Now, the goal of the question seems to be find phi x and find phi y. Would be our apparent goal here. So, how do we find phi x and phi y? First of all, work on your phi x and phi y formula. So, what's the u in the x direction, guys? U in the x direction? It's in the top right corner. 40 root 3. 40 root 3, and then any deceleration in that direction? It's technically minus g sine theta times t, but we like to keep the g and t together. gt sine theta. What about phi y? In the phi y direction we have 40. So it's going to be 40 minus gt cos theta. Moving over to sx. The u value is 40 root 3 t. And then minus a half g t squared sine theta. It's still the g sine theta part. That's still there. That's the acceleration we're using. And the part after that, guys, it's going to be 40 t minus a half. Anybody? gt squared cos theta. Because remember, cos theta is the one going up and down. That's in the opposite direction to Vy. That's along the Vy axis. G sine theta is along the x-axis, or our x-axis. Now we have that made. To properly make the phi x and phi y function work properly, we got to find its speed as it crashes into the plane. Does everybody agree with that? The reason we're going after this is it gives us the tan of the landing angle. We know that tan of the landing angle is phi y over phi x. Therefore, we must get phi y and phi x at the time of flight. Can anyone in the class tell me how to find the time of flight? What happens at the very end of the question? How high are you off the ground? Sy equals 0. So we're going to solve Sy equals 0. So we're going to get is 40t minus a half gt squared cos theta equals 0. Multiply everything by 2 and then transfer that over to the right. I'm going to get 80t equals gt squared cos theta. I'm going to cancel that t with one of the t's there. I'm going to isolate t, and I'm going to get 80 over g cos theta. This is known as what, guys? Time of flight. It's how long you're in the air. Similar idea, but it's known as time of flight, okay? Next, I'm going to plug this value into the phi x and phi y equations that I'm bringing down now. So what we're going to do is we're going to put them in here. So get ready for some trigonometry. So what we're going to get is phi x at time of flight is 40 root 3 minus g sine theta multiplied by the time of flight. I'm just isolating the t's. And I'm going to replace that with 80 over g cos theta. The g's cancel. And I'm going to have sine theta over cos theta, which will turn into what? Sine theta over cos theta, anybody? 80 tan theta? Everybody alright with that? 80 tan theta? Yeah, you should be. Alright. Now, phi y, guys, is 40 minus g cos theta multiplied by the time. What's the time again? 80 over g cos theta. Now this one's interesting. G will cancel with g. Cos theta will cancel with cos theta. If we do this right, phi y has to be positive or negative. Gotta be negative. And long behold, phi y is going to be 40 minus 80, which is going to get me minus 40. So, it's currently landing on this slope here, And what it's currently doing is it's going across a phi x and it's come down a phi y, resulting in a landing pattern specified by the pink line. Okay, and this landing pattern is angle alpha. And what we have is this is 40 downwards. I'm ignoring the minus sign using my formula. And the other one is 40 root 3 minus 80 tan theta. That's guaranteed to be, what's that word? That's guaranteed to be positive anyway. So I'm going to get tan alpha equals 40 opposite over adjacent divided by 40 root 3 minus 80 tan theta. And it tells you what the landing angle is, doesn't it? Where is it? 2 over root 3. It's handy out. Okay. Alright. Going to divide both sides by 2. I'm going to multiply that by root 3. 20 root 3 equals 40 root 3 minus 80 tan theta. I'm then going to bring the 80 tan theta to the left. I'm going to bring that 20 root 3 to the right. Take that 20 root 3 away from the 40 root 3 to get 20 root 3. I'm going to get tan theta, therefore, is going to be root 3 over 4. So we need to get the angle in isolation. I do indeed. Tan inverse that. And what do we get? Hopefully you'll have it here somewhere. 23.4 degrees. Just somebody check that out for me. We good? Yeah, thank you. Now, the speed at which the particle strikes the plane. The speed, okay? We go back to this triangle here. Where's this one here? Okay. We know that this, what I'd say is the better way to do this is using a surd form, right? Just do a quick, that's angle alpha. Just do a quick sine cos tan triangle, okay? Root 3 over 4, right? Square both of them. It's going to be 16 plus 3, which is the square root of 19. This means that sine alpha is root 3 over root 19, and it means cos alpha is cos alpha is what's it, 4 over root 19. I don't even think I'm going to need that, to be honest. I can do it this way anyway. I could do it two ways. I could substitute in the value for theta, and then find this value in decimal form or surd form. Do Pythagoras' theorem to find out what is the actual velocity. The way I chose to do it is slightly quicker in my opinion. See the way that's a 40, and I'm looking for the hypotenuse. I'm just going to use sine alpha equals 40 over x, and therefore x will equal 40 over sine alpha, and I found out my sine alpha to be what? Root 3 over root 19. Can somebody put that in the calculator for me? 40 divided by root 3 divided by root 19, which is 52.9 in decimals. Is it 52.9? Just one sec there, guys. What we made was a quick mistake with that. The method was perfect. Everything here is absolutely perfect. The only thing that's not perfect is the fact that we used the wrong triangle for alpha. So we're just going to quickly rub this out. What we said with alpha was that alpha is tan alpha is what's it? 2 over root 3. So 2 divided by root 3. Find the hypotenuse of that, which is 3 plus 4, which is root 7. This means that sine alpha is 2 divided by root 7, which means that instead of having root 3 over root 19, we were meant to have 2 over root 7. Try that in the calculator, and I'm hoping that we'll get 52.9. Oh yeah, sorry, it's not root 2, it's just 2, isn't it? Okay. And 52.9. There we go. So speed is 52.9. Okay,